Today, we are speaking about the state of the art in autonomous robotic systems. Frederick Brun, who is the CEO of Unibap, and Dr. David Bray, who is the executive director of People-Centered Internet. And he's my guest co-host and subject matter expert this week. Frederick, how are you? And welcome to CxOTalk.
Hello, good day. It's good to be here. We're calling in from Sweden. It's really grateful to join you.
And I see you have a friend back there behind you.
I sure do. This is the virtual impression of Batu, which is a robot that is actually doing autonomous assembly and different sequences for smart factories.
I can't wait to meet Batu in more detail. And David Bray, how are you? And welcome back to CxOTalk.
Doing great, Michael, and thanks for having me on CxOTalk. Really excited to hear more about what Frederick is doing with Unibap. Incidentally, we're both Eisenhower Fellows as well. That's how we actually originally met.
I'm excited. So let's begin. Frederick, I think we should start by asking you to tell us about Unibap.
Unibap is a company in two different areas. We're doing smart industry automation, and we're providing space cloud computing infrastructure for spacecraft. And you may ask, what does space and smart industry do together? And what's interesting is that they are very closely related and connected. Because if you have a smart factory where you provide inline AI that has to work like a human 24/7, you cannot have any standstills, which means that you need to do a lot of remote maintenance, you need to have very reliable systems and uptimes. And there's the connection over to space, because in space you can obviously not reach your product and do real maintenance on it. You have to do it remotely, and the uptimes are very similar as well.
David Bray, tell us about your work.
The People-Centered Internet, we do demonstration projects that measurably improve people's lives and livelihoods. VentSurf is our chair, Mei-Lin Feng is our co-founder, and projects include, for example, helping groups that have not gotten internet access find a way that's affordable and accessible for them. Also thinking about what we can do to counter misinformation or disinformation, and thinking through the future of work that includes AI and automation and things like Frederick is doing with Unibap.
Frederick, what are the fundamental problems that you're trying to solve?
What we're actually creating at Unibap is virtual operators, where we train robots to have the same knowledge and understanding as a human. So when we put our systems into smart factories, they are basically a high school engineer taught to know what assembly or grinding or drilling or painting, coating, quality assurance is like. And then when they work inside the factory, they learn. So after about 6 months to a year, you have a master's degree, and about a year and a half later, you have a PhD level. So what we fundamentally change is the way of production, so that you really have virtual operators that can allow you to have higher production rates and a lot more control of your processes.
How is that different from what we have in factories today? Because just in general in factories, isn't there a push to lower the skill requirement for people working in the operation?
That is absolutely true. The big difference here is that AI that we deploy inside the factories allow you to have a truly virtual operator that behaves like a human. What you see in factories today is a lot of static automation, where you have certain softwares that repeatedly does the same thing, but they cannot compensate the same way that a human would do to errors or to changes. And typically you would also have a jig that allows you to do the same thing for a large batch. In our case, when the system understands the reality like a human, it can actually go down to one part manufacturing, because it can change from every single step from second to second.
And I guess, Frederick, is this now possible because of computational cycles? Is this now possible because of advances in computer vision? Why now, and what do you see as sort of like the secret to why this is possible to have machines that learn next to a factory worker?
There are many different reasons why this is appearing now. One of the most critical aspects is the computational performance. It hasn't been there. But as many viewers know, AI hasn't been new. It's been around for about 50, 60 years. But now when the computational performance is getting really good, and we are also being able to harness the power of deep neural networks, which really changes the way you can do AI in practical applications, that's really an enabler. And also, if you look at the research environment, there has been significant progress over the last 5 years on algorithms that allows us to much faster train systems together with humans, and in certain cases cut the human out of the loop completely by training on only known good parts.
Would you say that the problem you're solving, does it fall mostly on the robotics and the hardware side, or is the balance on the AI and the software and the data side?
So that's a really interesting question, because we're at the turning point where human and machine start to operate a lot closer. So I would say it's about 40% hardware and about 60% software. And the software part of our business and the realization of this is only increasing for every 3-4 months. So we're seeing that we're turning more and more into a data-driven software company than hardware. But this because of the reliability issues that I talked about. So if you're in a factory, you really have to work all the time. You cannot have any downtimes. It's very important that you work with the hardware and software together, because they have to be very closely matched. And you also have to change the software a little bit to include things for safety and reliability that typically wouldn't be inside a standard package from AVS, for instance.
And Fredrik, what are you finding as people work next to the robot and help train it? Are you finding that they appreciate it? Are they finding that they're surprised? What responses are you finding from workers working next to a robot?
We have customers that represent both ends of the spectrum, I would say. We have customers that have already taught and already internally in the company created a digital transformation agenda where this has been discussed for many years, and they started preparing their employees for this change. We have other customers that haven't started this journey yet, but are exploring this. And we're seeing everything from really helpful people saying that I'm really happy that this dull, dangerous and dirty work can be automated so that I can participate and do something safer, better for me, to the other spectrum where people saying that, okay, I'm going to sabotage this because I'd like to keep my job the way it is.
It's a complex set of problems because you've got hardware, software, data, and then human interactions, which includes the human attitude. So you're kind of in this intersection of a lot of complexity.
Absolutely, and that's our reality. And if you look at the skill set of our company, it's truly amazing because we have an interdisciplinary workforce here that is just amazing. We have attracted the best talents we can find in this country and possibly even worldwide.
And are you finding as well that is there appreciation for the fact that maybe the robot can do things that a human simply can't do? Can it see things, or can it see imperfections that a human eye can't see? Can it lift things that would just be too heavy for a human to do? Is there any appreciation for that?
Absolutely, and that goes back to the dangerous part of the workforce where you have jobs that are really stressing on you. A system like this will do the same thing over and over and over, and they will obviously see things the same way, even if a human would be tired and start to miss certain things. A system like this doesn't do that. It stays the same all the time. And if you look at the different jobs that are being automated first, those are the 3Ds, the dull, dangerous, and dirty work. So those are typically related to mining, it's heavy machinery, it's painting, where you have a lot of bad environments for your health. Those are the first one that we automate, and the most people that we meet are really happy that this is getting done, because then you can move on to a better job.
What are the significant challenges or the hardest challenges that you face as you're dealing with these various systems?
Those are really different depending on area. Some of the really big problem that is common between the areas that we operate in is trust. So to gain the trust of the customers that these systems will behave as good or better as the humans over time that's really a big threshold for the entire market to break through. And if you take all the other parts and you look at hardware, software, all of that can be discussed. You can show with real numbers that it's really robust and reliable. But when it gets to trust, that's more driven by the appearance, the feelings of people. And to have a good trust in a system means that everyone has to see it live for a time period to really believe in it.
So in some respects, you're saying it's not just that the machine is learning from the humans, but then the human organization is watching and learning whether or not they are willing to trust that the robot can be reliable.
Absolutely, that's exactly what I'm saying. And a good analog is our autopilots in commercial aviation. So not a lot of people knows that an Airbus A380 from Frankfurt to San Francisco is only human operated for about 5 minutes out of a 13-hour flight. The rest is autonomous. But we still like to see that pilot in the front. But the pilot doesn't do much today.
Right.
It goes back to trust.
Fredrik, where all of this fits into manufacturing, and compare and contrast what's going on today with what you're making possible.
What we're making possible is the ability to increase production rates, because when you have a human or a virtual operator that operates like a human, we can actually scale that speed of operation, because we can invoke very large computers and run these systems very fast, much faster than a human can reason. The other aspect is that if you digitize everything, so in our case, when we do manufacturing where we can do real-time inspection of 100% of the parts, you can really optimize your yield, you can optimize your entire production flow, and we can create data that can be congregated on a higher fabric level, so you can compare your different manufacturing lines, your different manufacturing sites. And you can push really manufacturing between one site, for instance, in the US and one site in Sweden with a button of a click. You click a button and then you move your manufacturing around globally, and you have the same quality, you have the same virtual operator regardless where they are. So you get a much better standardization than you do with humans.
Fredrik, I know when we were talking in the past that really sort of underscored the importance of what you're doing is that of safety. You were talking about there's certain parts that have to be manufactured to be able to withstand certain stresses or certain strains, and if they don't meet that quality, it can actually result in something catastrophic or explosive. And so there's an element of there's just increased assured safety, would you say, with results of what you're doing with robots?
Absolutely. The different operations that typically is done by robots, like welding and assembly and grinding and drilling, things like that, mostly comes with a lot of quality inspection that is today done by humans. So when you can start to combine these different elements, you get a much higher quality overall, because these systems will do the same thing every time. So that really means that if you have a high value production, you create parts that are safety critical or they are of high value. This is tremendously important, because from this you have the same quality all the time. And if you have any manufacturing errors, that can be quickly detected and removed from the production line. So we have some really good big volume customers that we have shown to be able to lower the quality losses by 13-14%.
Maybe if we could talk a little bit more about Bato, or the robot behind you. Tell us a little bit more how it can sort of deal with things that it's never seen before, or deal with parts that it's never assembled a specific way before, but using computer vision can actually let you know if it's actually possible to build something or not.
I will go into a little bit of explanation here, and then I hope we will be able to run the robot live for you guys so you can see what I'm talking about. But what we are doing is that the robot behind me, which is a universal robot, that one is actually just like the arms and the legs of a human. So at the tip of this one, you have one of our intelligent vision systems. That's really the core of the intelligence. So we sit over the robotic control system. So what we do is that, given a number of CAD models and a task description, we ask this robot to please do an assembly sequence. So we've taught the system the meaning of pick and placing, for instance. So now with a few CAD models and a task list to assemble a stack, we can ask the robot digitally to do that for us. So the robot will look around and see, do I have the parts that should match whatever that comes from the CAD? And then it looks at the task list and say, okay, you want me to do pick and place. Ah, that's great, because I understand the meaning of pick and place. And that means that this system in real time can start to reason about the task and the objects. And it will actually generate the code needed to do this in real time. And the big application of this in industry is that you can shorten the time from design to manufacturing. And that's really why you can go down all the way to one-part manufacturing, because you can change the drawing all the time. So if you have a different assembly sequence for different customers and they order one of something, that really doesn't matter to the system, because it will figure out the code to do that when it's needed. And that's truly a big change, because previously industrial robotics has been about programming, large volumes, jigs, always trying to keep everything the same. And if you need to do reprogramming, you do that in a safe environment. In this case, I will stand next to the robot as it reasons on the code needed to do what we're going to ask it to do. And that's really a tremendous shift.
When you say the reasons on the code and develops the code, can you tell us what specifically you're talking about?
What I'm talking about is that an industrial robot's taking commands for left, right, up, down, grab, release, things like that. And this robot doesn't know that code sequence behind me right now. So when we give it the task to assemble something, it will reason about that code and generate the code commands that need to go to the industrial robot controller to move it around the way we want it to move.
And sort of by analogy, because I right now have a 2.5-year-old, it's sort of like when you ask a 2-year-old or a 3-year-old to pick something up. You know, you're not giving specific instructions, but it's looking where the objects are, it's looking at the orientation, and a child is reasoning how to pick it up. What you're saying is similarly here, unlike conventional factories where you have to explicitly tell them go up, down to pick it up, it's reasoning on its own how to go about doing it. And then if you told it to put it in another place, how to then put it in that place, which does raise a interesting future, which is we could see in the future, for example, for buildings where you need to finish the walls, the ceilings, the floors with different fixtures, different tiles, different flooring, different windows. If you had CAD images of each of the different floors of that building, and you had a palette with the different supplies available and a series of these robots that could recharge themselves when they needed to, you could, in theory, tell the robot, go forth and actually finish each of the floors of this building for me. And as long as it had the CAD images and it had the parts, it would work 24/7 to finish that.
Absolutely, and that's a great example, and that's something that is actually being prototyped here in Sweden with construction companies now. So that's not too far away in the future, actually, to be able to do that.
Do you want to show us your robot friend?
Absolutely. So if the viewers can live with a little bit of background noise, we will run a demo for you here live now. And we're going to ask this robot now to start and to assemble a stack of blocks. And these blocks, it's difficult to see in the live video, but you can actually see some differences in the blocks. And at the top block will say Intel, because we have an Intel corporation with it. And it's only one of these 4 blocks that have that. So with a little bit of magic now, the demo should start. And as it moves around in the background, we can continue the discussion. But this system now has started to reason about the task it's been given. So it knows the shape from the CAD of the blocks that you see here on the table. And it has the understanding of picking and placing. So given the task that it should take 3 of these blocks and put them together in a stack, it's now reasoning about, okay, what's the size of the first block? What's the size of the second block? What's the size of the third block? How do you want me to stack them? Oh, you want them to be stacked this way. Okay. So if you want it to be this way, I have to move around and perform the operations that way. And what's interesting here is that you see no jig, because this is picked and assembled on a standard desk. So as long as you can mount a robot arm on it, we can use whatever desk or surface area you have as the factory. So what you see now is that the robot has assembled an arc. And maybe you're able to read that it says Intel on top of it. And in the CAD model, which the viewers can't see, it's actually being asked to put that block at the top. And now it will begin a sequence to disassemble this as well. So what's interesting here is that it's just a desk and a robot and a vision system connected to it. And then you go directly from your CAD models.
And I think what's astounding to me is, there's nothing that's, like I said, there's no jig, there's no grid pattern or anything like that. It's again, you literally just put the computer on, you put the robot on the desk and you gave it how you wanted to build it, and it did. There's nothing else giving it any sort of spatial orientation or anything like that. That's quite impressive.
In contrast to traditional robotics, where you have fixed programmed pathways.
Correct. So now it's taking this stack apart again, but this is just showing the skill module or the virtual operator called pick and place. So what you can do now is that you can take your entire toolbox with quality assurance, with drilling, with, in this case, pick and place and assembly. So you can take that entire toolbox and put that into all sorts of various combinations. So what you're seeing here, this is done with a universal robot, but what we have done is that we have demonstrated this together with Universal Robot and also ABB, Kuka, Fanuc, and Yaskawa from Japan. So we can really do this with almost any industrial robot that you can find on the market today.
So the ultimate flexibility, so it's not just an issue of cost savings, but really you're talking about manufacturing agility.
Correct. And that's really the beauty, because now you're agnostic to the volume you have, you're agnostic to a lot of the design requirements that you have today, because this system behind me will reason like a trained high school engineer. And you just need to pick together the various virtual operating modules that you have an interest in.
And to take the analogy even further, what you're saying is we now have the ability, if you're shipping something, say it's circuit boards, you could have each circuit board would be custom tailored to whatever requirements someone had, or even something like as if it's like teddy bears, each customer could customize what the teddy bear is carrying, what the nose is, or something like that as the robot does it. And that doesn't impact your scale because the robot's able to handle task on demand for customization.
Absolutely. You nailed it on the head. That's exactly what this is about.
What kind of skill is required to program the robot, and how does that compare to the setup of traditional robots?
So what's interesting here is that anyone with a little bit of CAD design capabilities can program this robot. Actually, anyone can program this robot because it's not being programmed at all. It generates its own code when it's needed. So given the task, given the operating modules that we have taught the system, you can take a CAD sequence directly to operation like this. So as long as someone has made those CAD drawings in this case and created that sequence of assembly, for instance, then the system will figure it out itself. So the actual code that runs the robot is being reasoned.
And because we started off the conversation talking about you also do things in space, I imagine this is clearly a future application for space where you won't be able to tell the robot everything you want to do, partly because that's, the mission parameters are so large, but then also too, there's communication lags. And so I imagine the future is, especially in space and space exploration, we send robots like that out, possibly to mine asteroids, possibly to do research or something like that. You give the high-level objectives as a human, but beyond that, the robot's left on its own to reason about how to collect that ore sample or to collect that sample from the soil or whatever.
Absolutely. One of the big applications in space is robotics, and you're going to the moon to do mineral excavation, for instance. You're talking about building Mars bases, and those going to be highly autonomous missions where you have all sorts of robotic vehicles cooperating. And for us, it's really the same. So the space infrastructure that we have created, the radiation-hardened boards that runs x86 code, is actually running the same code that you see behind me. So we can reuse the entire software infrastructure. So now you can really start to take autonomy to another level in space based on industrial existing code rather than develop new code all the time for exotic architectures that is currently in space.
And the robotic hardware, I'm assuming, is that the arms and the movements are the same as other off-the-shelf robots, so to speak, or are there special complexities and special features that you've built in?
That's an interesting question. So what you see here is one of the standard industrial robot arms that you can buy. What we do is that we interpret our code and convert that into the protocol that this robot is talking. But if you're going to have the level of reliability that we are requiring in our applications, you have to do a bit of tailoring on the hardware also. And that's, again, a combination of space and industry, where we take design rules from autonomous systems in space and apply it for industrial applications. So in this particular case, this vision system is built with space technology to provide a level of reliability that you don't have in a commercial vision system on Earth.
And one of the things that we were talking about a little bit earlier, Frederick, was that how this does require you to have computing at the edge, that you're dealing with several teraflops of computing power actually on the robot itself to do the imaging, to do the awareness of how to put things together and the reasoning. You can't do this remotely, say, in a distant cloud or something like that. You have to have computing at the edge as well.
Yes, that's correct. Actually, in this particular demo, the computing task is divided between the robot and an edge node, which sits under the table here. But if we would have a cloud connection, we would have multiple problems. We would have latency, which would be a big problem because this is a safety-critical robot. If this robot goes haywire, it could kill me. So that's one important aspect. The other aspect is the uptime that we talked about before. If you're in a critical line at the production site, that one is never allowed to stop. So you can imagine what happens if the 5G network or 4G network or your fiber connection to your cloud provider goes down. That means that your entire factory is standing still. So what we have to do is partition our services, that we have a high degree of autonomy localized in the factories, and we can provide additional services on top of the cloud, but those cannot be part of the critical loop.
So what is your business model?
There isn't one business model that fits all, but the business model that we tend to drive for is data-driven. So you would come in and ask us to provide a service. We would partner with an integrator that provides the robot and the infrastructure, and then you would subscribe to our skill modules to provide the service. So if you want to do assembly, you want to do quality assurance, you want to do drilling, you want to do a little bit of pick and place, you would subscribe to us for those modules, and then those modules would run locally in your infrastructure. And you would pay a tick or a royalty per produced unit or a monthly license fee, quite similar to Spotify or YouTube Premium or anything like that.
We have a couple of questions from Twitter, and one hits on a point very much as you just described. Arsalan Khan says, in the future of work with robotics, should we create residual income streams for the people who create these systems? For example, actors get paid for reruns of their shows.
What's interesting, in Sweden we have a very big forest industry. It's primarily in the north, and there are not that many people living in the north. So what happens is that we are harvesting the forest in the north, and we're paying the taxes to the major region of Stockholm, where we spend most of the money. So there is already a discussion in Sweden being had if we should allow more of the exports to stay where you have the raw material. In this case, in Sweden, that means that more of the money from forestry would actually stay up north in those regions. Very similar to robotics like this. If you have a data-driven module where you subscribe to various modules when you need them, you could actually go in and tax that.
And I think what you're really getting to there, Frederick, and I concur, it was a good example of thinking about, robotic software as a service, robotic data as a service, and you could also imagine robotic hardware, the people that will maintain it. And so it may very well be much like how we've seen several companies where they don't actually own the assets themselves, but instead they're brokering the connections. There may be companies that broker the connections between the people that have produced a hardware, produced a software that's now being used and will be updated as it's needed, and the people that are helping to maintain the systems. That same sort of thing, it may very well be the future of a factory, is you don't actually own the hardware that's there, but instead you are brokering the context in which the confluence of hardware, software, data, and then the people on your factory floor come together.
Absolutely.
One other question, as we were talking about with the edge computing, it seems like this also points to a future in which in space, right now we send a lot of data down, especially of images or things that we pick up from space. But when you have that computing power available in space, it sounds like you could actually teach the machine or teach the satellite what things that you actually care about and what things you don't care about. And so it doesn't need to consume that bandwidth to send back things that you're not interested in, but it can only send the things that you're really interested in coming back based on what you've taught the machine at the satellite's edge as opposed to on the ground stations. Is that something that you're also working with computing?
That is one of the major applications of our space infrastructure to do that, especially if you combine it with reinforcement learning so that the systems can actually learn in route and in situ what to look for, even though you don't have to tell it from ground how to do that. So you can just imagine if you're at Mars or even at Jupiter and you have a 20K bit line back home to Sweden and you have sensors generating 16 gigabits per second. How do you get those 16 gigabits per second through a 20K bit line? Well, obviously you don't. So you have to do a lot of in-orbit processing. So this has been done for many years, but it's been mostly about compression and taking out pixels from images. And in our case, a system around Mars or even on Mars can reason about how to assemble a hotel, for instance, or a storage room, or it can reason about where to find water and things like that in real time.
We have some more questions from Twitter. Ginny Hamilton wants, and she's not joking, wants a robot that can fold laundry. The business model can be something like Peloton, where essentially it's rented. Why can't you do that? Why haven't you done that?
Actually, there are people doing that. I don't know if you've seen the pancakes robot, but you can actually buy, I think they're even available on Amazon. You can go out and buy a robot today that will flip pancakes for you. So these guys are starting to appear, and I'm quite sure that there are laundry robots available, maybe for big hotels so far and not for consumer market, but they are starting to get there. And the reason why we are not doing that is that we are targeting manufacturing industry because we cannot be everywhere. We are a fairly small company so far. So we are laser focused on smart industry and space, but this is definitely a market that will explode going forward with all sorts of applications.
And what Jenny's question made me think of, Frederick and Michael, is it could also be where you don't actually have to buy the robot to do it. If this robot's on wheels, you could have an app and say, I want, and it can be dynamic pricing, I want to schedule a robot to come to my house to fold the following laundry, and it will come up as it's available. Maybe it'll even let itself into your house if you let it. It will fold your laundry, and then again, back on wheels, it'll go to the next house where it actually has the next task to do. But it could be a very future where you don't actually have to buy it for your own house, but given they're on wheels, they're going about task to do the laundry folding on demand via an app.
Absolutely, and this is truly the remarkable thing. Can you believe just 15 years ago us having this conversation, and now when we're having this conversation, it's actually going to happen within 5, 7, 8 years.
Right. Agreed. And I would even say, could you believe we were having this conversation 5 years ago? I mean, I think we will be surprised, like you said, by how much the world changes 5 to 8 years from now.
We have another question from Twitter, and Sal Rasa is asking, given that you work across multiple industries, is there some notion of cooperation in helping us understand the nature of the services that you provide?
It's a very good question, and yes, there is a tremendous amount of cooperation between various companies. So this is so complex that almost no entity in the world can do this by themselves. We have to cooperate in the community. We have to cooperate between various business areas, between different markets even. So there is a lot of collaboration in this.
You're creating essentially the platform for the hardware platform, which is the robot itself. You have the software platform, which is the AI, the algorithms, and you are applying this to the specific industries and focus points. But correct me if I'm wrong, the hardware platform would be fairly agnostic, same with the algorithms. And so therefore, it's the industry expertise embodied in the data that brings your company the uniqueness to work in these narrow domains that you have chosen to focus in. Is that accurate?
Yes, that is 100% correctly, and that's why we're really a data-driven company, even though you see a robot behind me, because we are instantiating those virtual operators that are trained together with professionals that's been in industry for many, many years. And when we work with big Swedish companies with a worldwide presence, we train the operators, our virtual operators are trained here in Sweden.
That also just suggests, Michael, that really what's going to start to happen is whomever is the first mover into a specific industry vertical to start actually beginning to curate data on how these machines work will have an advantage if they get there first relative to others that come later.
It sounds to me that the competitive differentiation here is not the robotic hardware, nor is it the software platform, but it's actually and even the algorithms. It's really the data that's embodying the expertise.
It's actually a combination. A lot of it is in the data, but it's also the way you set up your infrastructure and your software architecture. So our architecture allows us to have a very high reliability inline at the edge, and we can connect to the cloud, but we have zero cloud dependencies, which can guarantee the robustness of our systems. And if you look at many of the services that are out there today, they rely on external cloud-based services, so they cannot do this.
Have you ever had a robot do something that was surprising to you, something that you were not expecting that you found yourself surprised with?
In an interesting position now with one of our big customers where their operators start to trust in the system now, and it's become like a game between the human and the machine. So they are trying to rig the systems. So we are doing quality assurance, and they are adding pieces of tape to it. They are drilling holes in the parts. They are trying to mess with the system to see if we can detect that. And that's really interesting, because now we're at the cross-section where the trust is starting to be there, and it's like, yeah, I'm going to beat this machine.
Well, instead of humans saboteuring the factory line, they're trying to see if they can fool or beat the robot. Yeah.
Yes.
We have a couple of other questions from Twitter. This is robotics intelligence as a service. If that is is that his business model? If so, it's fabulous. So is that your business model?
Yes, in its ultimate form, that's what it is.
And we have another question from Twitter. Arsalan Khan asks a very practical and very important question. And he says, what are the barriers to adoption for these dynamic robots into traditional manufacturing?
So I would go back and say that it's all about trust. So the procurement officer at a big company who wants to buy this have to have confidence that they're buying something that they can rely on. Can you imagine, we had 150 years of industrial revolutions that's been based on the fact that you're buying a machine that will do exactly what you specified it to do. It won't do anything else, and it will wear down 20% every year until you discard it. Now you're buying a system that comes in as a high school engineer, does the same as the human, and it continues to learn and improve throughout its lifetime. So rather than degrading 20%, it's gaining 20% of capabilities every year. So it's a tremendous shift in industry. How do you procure this? How is it even possible to buy a really advanced piece of manufacturing equipment as a Office 365 license? It's really changing the way you have to think about manufacturing.
And that actually raises an interesting question. Would you charge more for a system that has been trained more and is therefore more savvy to a specific sector versus one that has no data set and therefore is new and novice at its task?
Now, that's a very good question, and that's a part of the complexity to these new business models, because now you can actually start to think like that. So instead of lowering the price, you can increase the price because you're giving more value to the customer over time.
So in that case, C-3PO in Star Wars should have been the most expensive droid ever, but yeah, interesting.
Well, that's an interesting aspect.
As we finish up, any thoughts on robots replacing humans?
My take on that is we're going to see a lot of robots displacing humans. We will also see a new labor market coming into play as well. The challenge is that in order to participate in the new labor market, you need to be reskilled or you need to be trained from the beginning in a lot of abstract thinking. And that's not for everyone. And that's really part of the challenge. There won't be any lack of jobs, but there will be difficulties getting to those new jobs.
Agreed. And then to amplify what Frederick is saying, I also think that that while there will be obviously some displacement, especially with the roles that are sort of dangerous or dirty and things like that, there's also going to be the augmentation, whether it's in the medical industry. You can imagine that the surgeon will also have assisting the surgeon a robotic arm as well, and that the robotic arm may be able to do things that a surgeon couldn't with more precision under stress. And so we need to think about both, what do we do about those people that are displaced completely? And as you said, can they be retrained, reskilled, or are there other things that we need to think about to help with that? And then what do we also do with the people that will be augmented? So they'll be working with the robot, and what the shift will be in terms of how do they relate and how do they work together as they move forward.
All right. And on those provocative questions, our time is up. I would like to thank Dr. Frederick Brun for being our guest here on CxOTalk. Frederick, thank you for being here with us today.
Thank you.
And I would also like to thank Dr. David Bray for being our guest co-host on CxOTalk yet again. David, thank you again for joining us.
Thanks for having me, Michael. Thank you, Frederick. And Michael, don't forget to thank the robot too.
Okay, Batu, dude, thank you so much. Everybody, thanks so much for watching. Before you go, please subscribe on YouTube and hit the subscribe button at the top of our website, and we'll send you great material about upcoming shows. Thanks so much, everybody. I hope you have a great day, and we'll see you again soon. Take care. Bye-bye.